Hello friends, welcome to Electronics for You. In this video, I will explain logical instructions in 8051 microcontrollers, and following instructions will be covered in this video. Okay, so these are ANL, ORL, XRL, CPL, CLR, rotate and swap instructions. Let's see them one by one. But before that, let us see various operands used in these instructions. The first one is A, which is nothing but accumulator. Then Rn, which is any resistance register in register bank from R0 to R7. So we are having 6 registers in each register bank. Then direct here will indicate the internal memory address for the 8051 microcontroller. @RI will indicate here indicates the indirect addressing mode, and RI is any register. It may be R0 or R1. Then hash data includes the 8-bit constant value which may vary from 00H to FFH, and register B will indicate is indicated by B. Let us see the first instruction. First logical instruction is the logical AND operation, which is indicated in case of 8051 ALP is ANL. Here ANL will be followed by destination byte, then comma, source byte. Okay, here bitwise AND operation. ANL stands for AND logically. So here bitwise AND operation will be performed between destination byte and source byte, and the result will be stored in destination byte, and the content of source byte will remain unchanged. These are the 6 different instructions in case of logical AND operation. The first one is ANL A, RN. Here every time left side operand will indicate destination byte and right side will indicate the source byte. Okay, in this instruction, and the content of accumulator and register RN is ANDed logically, and the result will be stored in accumulator. Next instruction is ANL A, direct. Here direct may be any address from 00H to FFH. Preferably 30H address is chosen, which actually indicates the internal memory location which is used for the storage for the data. Okay, here the content of accumulator and this direct memory locations will be ANDed, and the result will stored in accumulator. ANL A, @RI. Here RI may be R0 or R1, so the instruction may be ANL A, @R0. Okay, in this case it is indirect addressing mode, so @RI is indicating indirect address, and here @RI is actually for example, if in this case R1 is written and R1 is having value 40H, it means that R1 is indicating the internal address of 40H and the content of this 40H, and accumulator will be ANDed and result is stored into accumulator. ANL A, hash data. Hash data is directly indicating some data, 8-bit data, that is varying from 00 to FFH. For example, if hash FFH is written here, then the content of accumulator and FFH is ANDed and the result is stored into accumulator. Similarly, ANL direct comma A is also there. In this instruction, the content of direct internal memory location and accumulator will be added. The result will be stored in internal memory location indicated. Here it may be any address between 00 to FFH. Okay, that last one is ANL direct hash data. Again, hash data is indicating some 8-bit data, and direct is indicating indirect is indicating internal memory location. So the content of this memory location and this 8-bit data is logically ANDed, and the result is stored into this memory location. Now similar operation is performed in logical OR operation. It is indicated by ORL, or logically, followed by destination byte and source byte. Similar to that of AND instruction, again here the content of destination byte and source byte will be ANDed, will be ORed logically, and the result is stored into the destination byte. Similar instruction I have already explained in case of OR AND instruction. All these, this is OR instruction, this is also OR instruction. So OR, all these instructions are performed and the result is stored into the destination byte. Next is logical XOR operation. Again it is similar to that of AND operation. In this case also the content of the destination byte and source byte is XOR. Here XRL keyword is used for the XOR operation, and bitwise XOR operation is performed and the result is stored into the destination byte. Similar 6 instructions are there for the logical XOR operation. Now next instruction is complement. Complement, we can say that it is nothing but a NOT operation. So complement instruction is similar to that of NOT operation. Here only one instruction is used for the complement operation, and it is nothing but CPLA. Here CPL stands for complement, okay, and A stands for accumulator, means the content of accumulator is complement here. It means that every 1 is converted into 0 and every 0 bit is converted into 1. For example, if accumulator is contained is having 72H as its value, then 72H can be written as 01111, okay, this is 7, and 2 can be written as 0010. Now after CPLA instruction, if accumulator is having this value, after CPLA instruction, this is nothing but 10000, then it is 1101. Here it is 8 and this one is actually 8 plus 4 12, and this is 13 is ABC, okay, 10 11 12 13. Okay, so 13 is indicated by D. So overall after this instruction accumulator will contain 8D in hexadecimal. So this is the complement operation, CPL. Similarly one more operation is there, that is nothing but clear accumulator, CLRA. Here clear means make the content of accumulator as 0, means each bit will be replaced by 0, and after that any value in the accumulator will become 0. Next operation are again important. There are 4 types of rotate instructions. The first rotate instruction is RLA. Here R stands for rotate, L means left, and A stands for accumulator. So rotate left accumulator, this is our instruction. The content of accumulator is rotated bitwise by 1 to the left side, okay. For example, let us see it. If here the each bit will be shifted to left by 1, now the last bit will be D7 bit. In this case, for example, we are having 57 as our data. 57 is here indicated by 0101, this is 5, okay, and 7 is indicated by 0111, so this is our data, okay. Now in this case RLA instruction, it will shift each bit by to the left by 1. So here each bit is shifted likewise, and therefore the last bit here, remaining bit will be D7, and this D7 will go to this D0 bits, and therefore after this we will get result like this, okay. Here you can see clearly that 1 0 1 0. Okay, so 1 0 1 0, the first 4 bits are there, and later these bits are 0. Okay, 1 1 1. Okay, you can see it is 1 1 1, and this D7 bit is shifted to D0, that is 0 here. Therefore, overall, after this you will get result as this is 8 plus 2 means A, and this is nothing but E. So here the result after this execution will be AE. No flags are affected in this instruction. This is the rotate left instruction. Then next instruction is rotate left again, that is standing for RL, and C is indicating here carry. So rotate left through carry the content of accumulator. Okay, so rotate accumulator left through carry. This is our next instruction. This instruction is again similar to that of previous instruction. Only change will be here the bit D7 is placed in the carry flag, and the carry flag is placed in the least significant position, that is D0. Okay, so here is the example. Now consider similar data here. Okay, here carry flag is consisting of 1, and this is the data which is in our register accumulator. Okay, now each and every bit will be shifted to the left like this. After that, this bit, that is D7 bit, will shift into carry flag, and the carry flag will move to D0 bits, and in this way we will get a result like this. Here you can see this D7 was 0, and therefore it is shifted in carry flag. The carry flag was 1, and it is shifted in D0, and remaining every bit is shifted to the left side. This is the rotate left through carry, that is RLCA instruction, and this is the final result after execution. Next instruction is rotate right instruction. Again it is rotate accumulator right. Now each bit will shift to right, means D7 will shift into D6, D6 in D5, D5 in D4, and so on. Okay, here the last bit is D0, and that D0 will move to D7 bit. No flags are affected in this instruction again, and for overall you can see the result. If initially 57 is there in accumulator, after execution accumulator will consist of A, B as their as its content. This is RR instruction. Then the last instruction for rotate is RRC. RRC is rotate right through carry accumulator. Okay, now in this case each bit is shifted to right, but here carry flag is used. Now if carry flag is 0, okay, so this carry flag now will move to the right. Right means here it will move to D7 bit, and the content of D0 bit will be copied into carry flag. So overall we will get result like this. For example, accumulator is consisting of 57H previously, and carry flag is 0. So after execution the carry flag is 1, you can see here, and accumulator is having 2BH value. So each bit is shifted just in this way, and last bit is shifted here. So this is rotate operation. Next operation is swap operation. It is very easy instruction. Here swap A is the only instruction for that, and swap A will exchange, that is it will swap the nibbles within the accumulator. For example, accumulator is having 57 hexadecimal value, then after swap instruction this 7 is shifted to left side and this 5 is shifted to right side, and therefore we will get 75H. For example, again if it is consisting of 2B, then after swap instruction accumulator will be B2. Higher bits will be shifted to right, and lower bits will be shifted to left. So all these were the logical instruction. And friends, if you like this video, please subscribe our channel and press the bell icon for notification. And like, comment and share. Thank you.